Good morning, students. Good morning to one and all. Welcome to 3-1. Again, we are back to 3-1 here, and then we will take some more same revision classes for structural analysis 2. Here, first 2 units will be there for your mid exam. Mid exams will be mostly on month end. For second years, they started from Jan 9th. For you, maybe they will start from Jan 5th, like that. They will start from Jan 5th. Before that, for these 15 days time is there. In these 15 days, again, we will take the revision for the first 2 units. First unit already you know about the arches, and the second unit is slope deflection moment distribution method, and the third unit is Carney's method. Here, for our mid exam, same pattern we will mostly no objective. We'll give 5 more questions. In that 5 questions, you had to take any 3 questions you had to write. Now we'll share the same screen, whatever we learned in our last previous class. In structural analysis 2, same arches. First, you have to learn in arches. Again, we have only for 3-hinged arches only. We have formulas. In that only we had to solve some more problems for 3-hinged arches here. For the 3-hinged arches only, we had to do some more problems here. According to our previous problems, we will see. The next, when you will go for the slope deflection moment distribution method, in our structural analysis 1, we solved only for beams. For that beams only, they asked questions for whether it will be a sinking support or not, like that they asked in structural analysis 1 question paper. Here in structural analysis 2, we have frames. For that frames, you had to find normal slope deflection method and moment distribution method. Simultaneously, for that frames itself, we had to calculate the whether it will be a sinking, that will be whether it will be any deflections will be there or not, that has to be checked, and then we had to find here determined structure or indeterminate structure. And then here we will see the slope deflection equations and moment distribution equations for the given frames. Okay, this is the one of the method that we had to find here in structural analysis 2. Now first we will see some small starting onwards arches problems. This arches already we discussed here. For you, for 2 marks, they will ask about the arches for 2 marks. First of all, what is meant by the arch? It is nothing but a beam that will be in the form of the circular shape. All that one already you know. Here you can take this one, a beam that transfers the applied load to end supports by bending and shear action. That is nothing but here. What arch is nothing but a beam, but that will be in the form of a circular shape that will be transferred the load to the supports in the shape of the bending, and then there will be some shear action also will consider here. Okay. In this process, 1 or 2 points at a particular section is subjected to maximum stresses. Where is that maximum stresses means there will be at the top we will consider. Okay. In the arches, we will observe that the either 1 or 2 parts at a particular section is subjected to a maximum stresses. That where is that maximum stresses that we had to find here. Next, the third point is the horizontal distance from one span or from one support to another is called as a span. Span is nothing but the distance between the 2 supports. Here we are writing, sometimes they will ask what is meant by span of an arch. The span of the arch is nothing but the horizontal distance from one support to the another support is called as a span. This type of whatever the arches we have to observe, that will be for larger spans, and beams are very economical here, and many times there will be self weight will be there on the beams that will be continuous to the stresses in such large positions that has to be observed in the design for different design beams for larger areas. That type of large conditions, that is a more long continuous beams. In that continuous, there will be more number of arches will be there. In that conditions, we will see this type of larger spans. This larger spans we will see whether for bridges arches are provided instead of beams. In that conditions, we will see larger spans. The next one is arches are nothing but the curved beams that transfer the loads to their plane. Okay, arches. These arches may be developed. These arches are the structures that resist the applied forces, applied loads by developing the horizontal reactions at their supports, and then arches may be resist a normal thrust, and then some there will be some stone works and stone brick wood, some different types of the materials that are used for the construction. If you take in our normal interior decoration purpose, we are using wood. If you take the interior purpose outside the that is for appearance purpose, we'll go for the brick construction work. If you go for the arches for bridges, then we go for the stones here. That are all the main different categories of the materials that we had used. Okay, here you can observe this is our arch, but here you are observing this type of the arch will be for the normal bridges. This is our road. Okay, this is a span. Span of the arch is nothing but the one support to the another support is called as the span of the arch. Why you had to consider, if you take the, already I told you number of times, if you had to observe this our Tirumala road, there you can observe the one arches near Kapil Tirdam. There will be the arch will be there in the above the arch we'll observe the road. Wherever we are seeing now, we are seeing the waterfalls. In that waterfalls, below that waterfalls, you can observe this type of the arch shaped roads that has to be observed here in our road. Okay, there why how we can observe here means you can observe there will be a road will be there. You can observe that arches. Whatever the load, number of loads will be acting, moving from one place to another place in that road. That load will be carried smoothly to the sides. That is to the abutments. Okay, that we had observed here in our normal daily roads. Okay, here you can see why you had to consider this no, arches means whatever the load that is acting, it will not distribute directly to the ground. It will distribute uniformly and then sharing from one place to another place, and then it will changes goes to the direct to the ground. Okay, if you are not keeping this arches, what will happen? Whatever the suppose here, if you consider our condition, whatever the water is coming on the top, that water will be impact load will be acting on that road. Due to that impact load, what will happen? Already some vehicles are moving in that road, but again this wind effect and then water effect will be absorbed in that road. Then directly there will be some damages will occur on this road. That's why if you observe, there will be, we are considering some arches here. What will happen? Whatever the load, impact load is acting on that road, that load will be transferred, and then it will move wherever the abutment, wherever the strong piers are there, that is strong supports are there, that condition it will move, and then slowly it will move to the downward direction. This is one of the method we had to consider for the arches. Now we had to go come for our class. Here you can observe this one is the arch, the total rise of the arch, that is the total height from horizontal distance, not from the below the ground. Okay, below or above the ground. This one is our span. This one is our arch size. Suppose this one is our lintel. You have to observe like that from this lintel to the total height, maximum height of the road, that will called as the arch. Crown. We'll call as a crown. Sometimes they will ask what is meant by crown in arches. The maximum height of the arch is called as the crown here. And then the starting point is called as the springing point. That is the supports that we will call as a springing point. The arches that transfers the loads to the abutments and springing points, whatever the load is acting, that will be transferred to the side columns. There will be some hinges may be provided at their at these points here. We are providing some hinges also. And then the topmost point is called as a crown, which sometimes has a hinge for three-hinged problems. For three-hinged arches problems, we'll observe there will be a hinge will be there at the crown. Okay, the height of the crown will be above the support level is called the rise. That any section in the arch will be subjected to some normal thrust, radial shear, and then bending moment. If you take the arch here, this arch when we cut here, we have three forces will be observed here. One is a normal thrust, that one will be N. Another one is a radial shear that we have observed as a Q. And then one moment will be there on that arch. There will be three members will be there. That moment will be called as a M here. Okay. Whenever they will ask you to explain clearly about the arches in briefly, in theory means you have to write like this, and then you have to explain what are the internal forces in the arch. You have to draw the figure, and then you have to show what are the normal shear and then normal thrust, radial shear, and then moment. Had to draw the figure and then you have to explain. Okay. Next, we'll go for the, depending upon the support conditions, there will be the arches will be three types. Already this one we discussed here. There will be three-hinged arch and two-hinged arches, and then there will be a three-hinged arches, two-hinged arches, and fixed arches will be observed here. But in our syllabus, we had to learn about only three-hinged arches. Here you can see the single-hinged arches. This single arches is nothing but the two supports. It is will be around a two support, and it will be some fixed one. Only one hinge. Based on one hinge only, we are considering sides will be only they are keeping on the ground like that. You have to observe that is a single arch. Another one is a two ends are fixed. That one is a hinged arches structures. These are the different types of the arches that you have to observe. Next, we go for the forces that will be observed in the arches. Already we see in diagram. There will be normal thrust, radial shear, and then bending moment. Here, same for that we had to see the elastic theories. This one already we see in the last class itself. There will be the arch. There will be divided into number of parts, and then we are considering the arches and then different shapes. Directly we go for the formula. Our formula is to find the this one is the eccentricity, to find the eccentricity moment by the load. These are all not necessary. Directly we'll go for our formula. Eddy's theorem. Eddy's theorem also they will ask in sometimes. Eddy's theorem is nothing but it is very simple. Wherever we are considering according to our normal thrust and radial shear, there will be one first definition you have to know. Eddy's theorem is nothing but the bending moment at any section of an arch is proportional to the ordinate or the intercept between the given arch and the linear arch. The principle is called the Eddy's theorem. This is nothing but the whatever the bending moment we are considering for an arch is directly proportional to the intercept between the given arch and linear arch. Given arch and linear arch is nothing but here by graphical method we can observe here. This one is the given arch. This one is a linear arch. By considering these two conditions, this one is a linear arch. We are taking that arch, whatever the given arch changes to the linear arch, and then we are considering this arch will be in different form. Okay, now we'll see that derivation. Okay, the figure shows the two-hinged arches and three-hinged arches. For both, Eddy's theorem will be the same. We are considering there will be a three loads is acting on W1, W2, W3 like that. Whenever for an arch or beam there will be loads is acting simultaneously, there will be vertical reactions will be there at the supports. These vertical reactions will be at the support will be there. Let we are considering here some horizontal thrust will be there here. This one is a given arch. Normally, whatever we are observing, this one is a given arch. For this arch, we are considering there will be three loads is there, W1, W2, and W3. We are taking support A and B are the two supports. And then whatever the loads is given in that points also we are keeping C, D, E. And then for this support, there will be two reactions will be there, vertical reaction and horizontal reaction. These two vertical reactions are acting upwards, whatever the load is acting in downwards. The next simultaneously, you can consider the horizontals, two horizontals will be comes towards each other. Okay, then next we are considering some at a section of X, there will be a distance of YY here. For this, we have to first find where is the maximum bending moment will occur. Okay, this is a given arch. For this given arch, again we had to draw the linear arch. Linear arch is nothing but we are taking the same points, but we are taking instead of lines here. For this graphical method, you can observe here. When we will observe from the top OM, OP, OQ like that, we are taking here, and then we are taking the sizes, and then we are drawing the linear arch here. This one already you know according to our graphics, engineering topics. Once we see from top how will be looked, and once we see the at the side. Okay, here you can observe the like PQ and QR and RS are represents the loads, or represents the loads W1, W2, W3 on this load. That the line let M be the point such that MP represents the vertical. This one you observe. This MP will represent the PQ, QR or S will be the loads that are already observed. Then M is the center point from the starting line, and the P and S are the two other corner ends. This load will represent the MP. M be a point in such a that MP represents the vertical reaction, that is VA at a distance at A. And then SM represents the vertical reaction VB at B here. Let M naught represents the horizontal thrust. And then we are joining the OP, OD, OR and OS. This is according to our graphical method. I had to draw the figure, and then we had to take the polygonal pole. We had to draw the functional particular polygonal draw, and then we will find the directly we will go for the formula. This is our equation, combination of two arches due to the polar distance. To find the moment due to the horizontal thrust, whatever the moment itself we know already, whatever the force into perpendicular distance. Here we want to consider the moment at that point, means wherever the horizontal condition is applied or at support. For this, moment equals to moment at the horizontal thrust equals to our formula is H into Y. H is directly H is in a particular point, that will be the reaction will be the horizontal reaction H. That Y will be the vertical distance Y. Okay. Suppose if you take at a section of XX, XX means then we will get the H into Y minus HY dash. This Y into Y dash is that is nothing but we are considering the proportion limit. For a distance of XX, we are considering Y dash. Our Eddy's theorem is explaining, our Eddy's theorem is telling that wherever the movement is occurred, in that point there will be some horizontal reaction that must be multiplied with the vertical ordinates. That is the main Eddy's theorem definition. Movement, the net bending moment will be acting at that some section of X that must be equals to the whatever the horizontal distance or horizontal reaction H multiplied with the Y into Y dash. This Y into Y dash is nothing but we are considering as directly Y. Here the bending moment at any section of the arch is proportional to the ordinate or intercept between a given arch and the linear arch. That is, intercept between the, first we are considering as the given arch will be the Y and the linear arch will be the Y dash. The intercept of these two, Y and Y dash, is called as, this principle is called as Eddy's theorem. Here you see the definition. Hence, the bending moment at any section, wherever you are considering at X distance or at Y distance or at Z distance of any arch, is proportional to the ordinate of an intermediate between given arch and the linear arch. Whatever the bending moment M, that must be equals to the horizontal reaction multiplied by the, that is the proportional of the ordinate H to the given arch minus linear arch. This total will call as a principle of the Eddy's theorem. This is one of the main important ones. Simple, very simple. We have to take, we have to consider one normal section. For that section, for that arch, we are again drawing one linear arch. For these two linear arches, we are taking the A, B, C, D like that. Here in linear arch, we are taking P, Q, R, S. But in normal arch, we are considering at a section of X, the distance is Y. In a linear arch, we are considering at a section of H, the distance will be the Y dash. But the horizontal reaction is same. H will be the same, but both conditions for given and linear arch. According to our Eddy's theorem, what we had to prove that whatever the movement must be equals to the horizontal reaction H must be multiplied by the given arch minus linear arch, Y minus Y dash. This is our principle. Okay. Next, we'll go for the three-hinged arches problem. three hinged arches are statically determined. Why we will say statically determined? This one already you know. We have three equilibrium conditions is there, and then here three hinges will be there. How will say three hinges means at the two supports there will be two hinges will be there. At the crown one hinge is there. Three hinges minus three equilibrium conditions. 3 minus 3 equal to 0. Then that condition will call as a statically determined condition. Here, this three-hinged problem, three-hinged arches also, we are telling that it is a statically determined structure. This type of the arch has two hinges at the two ends, and also the supplementary intermediate hinge is there at the crown. Whatever I said in the before, same that one only. Here we are explaining this type of the arch has two hinges at the two supports, and then one hinge will be there at the center. Okay. Now we'll consider a three-hinged arch. Same we will see. Consider a three-hinged arch ABC, which is hinged at its support A and B, and then respectively C is pinned by connecting the joining the segments AC and BC as shown in figure. Now we'll see the figure. This one is our condition. This one is one hinge, B is one hinge, and the C is also one hinge. These three hinges will be equals to the three equilibrium conditions. That is, equilibrium conditions are three: sigma h equal to 0, sigma y equal to 0, and sigma m equal to 0. That will be 3 minus 3 equal to 0. If it will be the 0, then the structure will be a determined structure. Okay. Here we will consider the same arch of A, B, C by considering the three loads W1 and W2 and W3 of the loads acting at a distance of A, B, C, like that we are considering here from the supports A respectively. Whenever the support is there, compulsory there will be reactions will be there. That is vertical reaction and horizontal reaction. But here in this condition, these two hinges are at 2 points will be the only vertical hinge. Vertical reaction is there, not a horizontal reaction here. Due to the, this one will be the intermediate determined structure. Okay. Here, this is our given figure and given arch. For this arch, we had to find the maximum bending moment. Okay. To find the maximum bending moment, first we had to consider that there will be at a section of X, we are thinking that there will be a maximum. Then we had to find the, at a section of X, we had to find the Y. But the crown height is H is already given here. Okay. Now we'll see step by step. See, same arch we are drawing in the form of the beam. All of you observe here. This one is a beam, A, B is the support, and the C is the crown. We are thinking here one C will be there. C is a crown. And then we can observe the three loads W1, W2, W3 at the distance of A, B, C. Same arch we are drawing in the form of the beam. Okay. Now we'll see that taking the moments about C, we are taking towards at center of the forces on the left side of C. Then we have VA into up to C means L by 2 only, half of the distance. That must be equals to, here we are considering the only up to half, H into H. Up to center, we will get the W1 into L by 2 minus A per point load. If you observe the diagram, we are considering up to here. We then no need to consider of these two. Only first load only will come, VA into up to the half of the distance, L by 2, capital H into small h. We are considering the moment here, H into H. Another one is a W into L by 2 minus A. Okay. Now taking the moments about C of the forces on the right side. This one is for left side we are considering, we are getting this one, VA into L by 2 equals to H into W1 into L by 2 minus A. This is the equation 1. If some people will be there, why I want to go only left side, I want to go in the right side, like our, in our class, like Nitul, some persons will be there, Yashwant. Okay, they want to move in a difficult way, and then they want to move in different ways also. For that type of the people, we had to see the next condition. If you are not able to go in that difficult situation, means you had to go in the easy way only, then you can get the good marks. Difficult way lo velte rada ante not like that. You have to choose the two problems also. Okay, if you go for that one, if you consider from B side, what will happen? VB into half of the distance, and then VB side also one H will be there. That H into total H, H into H, plus W3 is the third load that is acting into L minus 2 by minus D, L by 2 minus D, plus W2 into L minus 2 minus D minus 3. That is the total distance. That one is already you know from starting engineering mechanics and strength of materials how to calculate this one. W3 into total distance up to center means L by 2 minus D will consider. If you take W2 means what will happen? W2 into L by 2 minus D minus C. That is our W2 distance. Okay. Now we'll consider the horizontal thrust that has to be at each support can be determined from any one of the equation. Better we go for the easy way, that is from first condition, VA condition. We are considering there will be a moment at a distance of x, moment at x equals to, our equation is VA into x minus W1 into x minus A minus H into Y. Here we are taking this whatever the VA into x into W1 into x minus A. Vertical loads, whatever the vertical loads from top to top to bottom, bottom to top, this will be called as a mu x. Okay, this one we are calling as a, this one is a moment, and then this one we are keeping the same H into Y. That is the horizontal distances we are keeping the same, but this one we are writing as a mu x. Mx equals to mu x minus Hy is our equation here. Okay. Here in this condition, mu x is nothing but the wherever the moment is acting, that moment we are considering here VA into x minus W1 into x minus A. This one is a normal three-hinged problem to calculate the moment and horizontal distance. Here we had to find only the horizontal reaction, capital H we want to find. Okay. For that type of the problems, simply they will ask derive an expression for a three-hinged parabolic arch means you have to derive up to here. Okay, this is one of the method that you have to observe here. Next one, we will see the next condition. The second one is the, we will see one small problem for this arch. This type of the problem they will ask for 5 marks on previous conditions. Three-hinged arch of span L and the rise is small h carries a uniformly distributed load W per unit run over the whole span, and then you have to show that the horizontal thrust capital H equals to at a support is W L square by 8H. That we had to derive here. Now we'll see the first we have to draw the figure. In the question they asked you, they will give the only like this question, you have to draw the figure. A three-hinged arch of span L, rise H, okay, carries UDL, total overall the span, like that they gave. You had to show that the horizontal thrust capital H equals to WL square by 8 into small h, that you had to derive here. Okay, now we'll see here. This is our diagram. First, you have to draw the diagram correctly. A three-hinged arch of A and B, and then this crown will be the C, and the height of the rise of the crown will be the capital small h. They gave capital A and capital B, and then the load is acting. The fully load is acting overall the overall the arch. First, you have to consider in the two reactions V and VB. To considering the two reactions, already we know how to consider the V and VB. Whatever the load is acting on that total, first you have to considering the total load is W, and then total distance is L here. Okay. Next, our V and VB will be the W into L by 2 and W into L by 2. You add these two, then you will get the W into L. VA plus VB equals to W into L, like that we can take. Okay. Each vertical reaction is WL by 2. That already we know how to calculate the vertical reactions. VA plus VB equals to W we had to consider, and then if you consider the moment at A, VB into total distance is L minus W into L into L by 2, then you will get VB equals to WL by 2. Then we had to substitute in the equation 1, VA equals to WL by 2, that two conditions will get here. That are the two each vertical conditions, vertical reactions I have to find. Once we'll find the vertical reactions, like the horizontal thrust at a section we had to find here. Taking the moment about C, at C is nothing but the crown, the forces on the left hand side we are taking here. That one is VA into L by 2. VA is nothing but WL by 2 into L by 2. VA into half of the distance equals to our formula H into H plus W into L by 2. That will get W into L whatever the load for a UDL, W into L by 2 into L by 4. Why you are taking L by 2 into L by 4 means actually we will take W into L into L by 2. Similarly, here also we are considering W into L by 2 is our total distance up to the crown into half of the distance, that is L by 4. Then W into L square by 4 minus this whatever H into H, I am equating all under to 0. W into L square by 4 minus H into H minus WL square by 8 equal to 0. Then WL square by 4 minus WL square by 8 equals to H into H. We had to find the capital H horizontal thrust equals to WL square by 8 into H. This is our derivation we had to find. 1 by 4 minus 1 by 8 equals to 1 by 8. Here we will get here WL square by 8 into H small h. This is our derivation we had to find for our three-hinged parabolic arch carrying the UDL. The horizontal thrust H equals to WL square by 8H. Very simple. And then if you solve clearly, if you understand easily means, then you can get the full marks. First, you have to consider the arch. Only for see, all of you first see, and then you have to observe. First, you have to draw the arch, and then you have to find the V and VB. Once we know the V and VB, then we have to take up to the center of the arch moment. You have to consider. To consider up to the center, what will happen? VA into up to the center is L by 2, and then capital H into small h is one condition that must be multiplied into W into L by 2 into half of the distance L by 4. We are equating all that, then we will get the horizontal thrust H equals to WL square by 8 into small h. This is our equation. This is our derived equation that we had to find here. Okay, this is very simple and then easy. You will get the 5 marks here. Okay, now we'll see one small problem for the three-hinged arch, and then I will stop the class. Here a three-hinged arch has a span of 30 meters and a rise of 10 meters here. They give the arch carries a UDL of 60 kilonewton per meter run on the left hand side, left hand of the its span. It also carries a concentrated loads of 160 kilonewton and 100 kilonewton at 5 meters and 10 meters from the right end. Determine the horizontal thrust of each support. For this type of the questions, you don't confuse. First, you have to draw the diagram correctly. Here they gave a three-hinged arch of span as 30 meters. First, you have to draw the arch. That the span is 30 meters. First, you have to draw. The next, what you have to take, next one is you have to read slowly, and then you have to imagine the diagram, and then you have to draw the correctly. Then only you will get the correct answer. First three-hinged arch, and then the span is 30, and then the rise is 10 meters. First, you have to draw the simple arch, 30 meters length, and the height is 10 meters. Okay. Next, what they asked, the arch carries a UDL of 60 kilonewton per meter on the left half of its span. Total arch is 30 meters they gave. Left half, left is the A. A is the left. According to our position, you have to think left is the A, and the right is the B, and the C is the center of the crown. Okay. From left to half of the span, a UDL is acting of 60 kilonewton per meter. You have to take the left half span, and then you have to draw the UDL, and then you have to figure it UDL, and then you have to show the diagram 60 kilonewton per meter on the left half up to 15 meters. Left half means up to 15 meters. The next, it also carries two concentrated loads. The same arch is also carrying the two concentrated loads now. That is, one is 160 kilonewton, another is 100 kilonewton. That already they said in the question. This 160 kilonewton is where it is acting, means it is acting 5 meters from the right end. That means from B point, if it go for the B point, from B to 5 meters distance, 160 kilonewton load is acting. Again, from B point, 10 meters distance, 100 kilonewton load is acting. That total you have to draw the diagram correctly. Once you will draw the diagram correctly, then the total problem will be the correct. We will get the good marks. 10 out of 10. Same question they asked in 10 marks. Okay, next we go for the next one. First, you have to draw the diagram. This one is our diagram. You had to first check whether the total span is 30 meters or not, and then the first 15 meters is UDL of 60 kilonewton per meter, and the next 15 meters there is a two point loads they give. 5 meters is 160 kilonewton, from 10 meters is 100 kilonewton. These are the 2 points they give, and then you have to draw the diagram correctly. Once you draw the diagram correctly, then you can go for the normal hour, whatever we had to solve that condition. Just 1 second, ma. Okay, now solve the problem. All of you, I think all of you know how to solve the problem. Once you had to know how to calculate the problem, now we'll start the same procedure. First, for a given problem, first you have to find the vertical reactions. Once you find the vertical reactions, then you have to calculate the next horizontal thrust by the given loads. Okay. First, you have to find the vertical reactions. What will be the VA and VB for the given loads? VA and VB for the given loads will be, you have to take, there will be 3 loads is given, that is from left side, one UDL is there, and the right side, 2 point loads are there. Okay, first find the VA and VB, and then you have to find the horizontal reaction. Here, I am taking from the right side, VB into the total distance is 30 equals to whatever the load is 160 kilonewton into 25 plus 100 into 20 plus 60 into 15 into 15 by 2. Here this one already you know. VB into total distance, 160 into 25, 100 into 20, 60 into 15 into 15 by 2. Then you will get the value of VB. No, I will consider from the right side means, okay, you can consider from the right side, VA into 30 degrees, 60 into 15 into 15 by 2 plus again this 15 will be adding here, and then 100 into 10 and then 160 into 5. You can get the value of VA. Okay, once you will calculate the VA and VB, VB is 425, and then VA plus VB is, our equation is 1160 according to the given loads. Then we'll consider the, we'll find the value of VA. Once we'll get the VA and VB, then you have to go for the moments at C, the forces on the left side. VA into half of the distance must be equals to the UDL, that is W into L into L by 2 plus H into H. H into capital H is, small h is 10 meters, already they gave in the rise of 10 meters. That we have to substitute here. And then we will find the horizontal thrust H value here. Okay. Only for this condition, they asked you to find the horizontal thrust H only. H equals to 427.5. If you consider from the right side, same, VB into L by 2 and the 2 point loads 100 into 5 plus 160 into 10 plus 10 H into 10. Then we will find the horizontal thrust H equals to 427.5. Okay, this one is very easy, ma. Next class again we'll see some more problems. Tomorrow, day after tomorrow classes, we'll find some horizontal thrust and radial shear for the same given problem. Today class, all of you please take one more problem for homework, and then you have to solve with this problem, same condition. Okay, all of you please note down the problem. A three-hinged arch of span, a three-hinged arch of span 50 meters, 50 meters and a rise of 20 meters. Okay, all of you please note down the problem and then you had to solve the problem and send me. Only had to find the horizontal reaction. A very simple problem. This one is again we are taking the revision class and then these problems are you had to do clearly. Here first of all you had to note down the problem clearly. A three-hinged arch has a span of 50 meters and a rise of 20 meters. The arch carries two concentrated loads. The arch carries two concentrated loads of 200 kilonewton and 100 kilonewton. 200 kilonewton and 100 kilonewton at 10 meters and 15 meters from the left end. The arch carries, again I am telling the same, the arch carries two concentrated loads of 200 kilonewton and 100 kilonewton at 10 meters and 15 meters from the left end. Same. It also carries a uniformly distributed load of 160 kilonewton per meter on the right side, on the right end, on the right half end. Okay, right half of its span, full half of the span. On the right half of the span carries a 160 kilonewton UDL. Determine horizontal thrust at each support. Determine the horizontal thrust at each support. That means HA at point A, what is the horizontal thrust, and HB from B side also we have to find the horizontal thrust at B. Okay. All of you please note down the question and then if you are not able to note down, you have to ask from your friends and then you have to solve this question and send me by today evening. Okay, students, same daily at least 3 or 4 problems you had to solve and then you had to revise the same problems according to our previous problems. Then you will get the good score, ma. Okay, okay, students. Okay, thank you, ma. If you have any doubts, you can ask me afterwards. From I think next week onwards, we'll get the total offline classes will be there. There you can solve by you itself. You can solve. I want the my seminar batch, ma. Roll number 1 to 10. I think structure analysis. Yes. Roll number 1 to 10, ma. Seminar batch, technical seminar batch 1 to 10. Nora. రోల్ నెంబర్ 1 to 10 టెక్నికల్ సెమినార్ బ్యాచ్ మీరు ఒకసారి నాకు తర్వాత కాల్ చేయండి. ఐ విల్ గివ్ ద సేమ్ 2 సెపరేట్లీ 2 డివైస్ సెమినార్ బ్యాచెస్ కి 2 టాపిక్స్ ఇచ్చేస్తాను. యూ హ్యాడ్ టు ప్రెజెంట్ ద టాపిక్స్ అండ్ దెన్ యూ హ్యాడ్ టు record the video and then you have to share to the Devyani ma'am. This Thursday, day after tomorrow, will be there for technical seminar for structural analysis 2. I had to prepare same whatever the topics we gave. For one batch I gave as fixed beams, for other batch I gave as slope deflection, I think slope deflection or moment distribution. I had to prepare the topics and then you had to present on Thursday. If you be prepared, all of you present compulsory 1 to 10 and then you had to present each and every student has to present the same seminar, same topic. Okay. Okay, students, thank you.